In this video, let us look at what comparable and equal matrices are. The first term is comparable matrices. Two matrices are said to be comparable if they have the same orders. So, comparable matrices are the matrices of same order. That is, if you have a matrix 1, 2, 1, 3, 1, 4 and 1, 5, 3, 2, 1, 2. This is a 2 by 3 matrix. This is also a 2 by 3 matrix. I say that these two are comparable matrices. That means I can compare whether they are equal or not equal. So, comparable matrices are matrices having the same order. Next, what are equal matrices? So, equal matrices are matrices which are comparable such that every corresponding element in one matrix has to be exactly equal to every corresponding element in the second matrix. There is two matrices A m by n is equal to B m by n. There are two matrices of the same order m by n. So these two matrices are said to be equal if Aij, the element in the ith row and jth column of A, is equal to Bij for all I, j, not just for a single I and a single j. This has to be valid for each and every possible value of I and j. So A11 has to be same as B11, A12 has to be same as B12, A13 has to be same as B13, so on. Every corresponding element has to be equal. Then we say that the matrices are equal. For example, if you have a matrix 2, 1, x 3 is equal to y1, 2, p. So, if it is given that these two matrices are equal, so can you find the value of x, y and z? Yes. So, these two matrices are equal. So, the corresponding elements have to be exactly equal. So, y has to be equal to 2, 1 is already equal to 1, x has to be equal to 2 and 3 has to be equal to p. P has to be equal to 3. So, if these two matrices are equal, every corresponding element have to be equal. And you can see that these two matrices have the same order. So, if the order is not equal, they cannot be equal matrices. So, I hope you understand what comparable matrices are and equal matrices are. Thank you.